My name is Muriel.
I'm Air.
I'm Kim.
We're back.
What does network model mean? Network model is a database model that is designed as a flexible approach to representing objects and their relationship. A unique feature of the network model is its schema, which is viewed as a graph where relationship types are arcs and object types are nodes. There are three types of network model. These are maximal flow, shortest route, and minimal spanning tree. Maximal flow involves determining the maximum amount of material that can flow from one point to another in a network. To find the maximal flow from the source or start of a network to the sink or finish of that network, two common methods are used: linear programming and the maximal flow technique. The objective of the shortest route is to find the shortest distance from one location to another. In a network, this often involves determining the shortest route from one node to each of the other nodes. Minimal spanning tree involves connecting all points of a network together while minimizing the total distance of these connections. There are four steps for the minimal spanning tree problem. First is to select any node in the network. Second, connect this node to the nearest node that minimizes the total distance. Third, considering all the nodes that are now connected, find and connect the nearest node that is not connected. If there is a tie for the nearest node, select one arbitrarily. A tie suggests there may be more than one optimal solution. And fourth, repeat the third step until all nodes are connected.
For the example problem, the company has a free shuttle ride to work from 7 bus stops within the city. Jimmy is in charge of the routing of this service. A network model is drawn below where there are 7 bus stops with a distance between them in kilometers. This problem may be solved using shortest route and minimal spanning tree. First, we shall solve this using shortest route. Help Jimmy find the shortest route in terms of distance from bus stop 1. First, determine the initial shortest route from the origin node 1 to the closest node, that being node 3. Next, establish a permanent set with the origin node and node 3 and determine all nodes directly connected to the permanent set nodes. Then, select the node with the shortest route or branch from the group of nodes directly connected to the permanent set nodes, the closest being node 2. Continue until all nodes have joined the permanent set. Once all nodes have joined the permanent set, list the optimal solution in tabular form such that all locations except the origin are listed in the first column. Then the next column will contain the route from origin until that bus stop, and the last column will contain the total distance from origin to that bus stop. For bus stops 2 and 3, there is a direct route from origin or node 1 with a distance of 16 kilometers and 9 kilometers respectively. To arrive at bus stop 4, the shuttle must first drive from node 1 to node 2, then arrive in node 4 with a total distance of 24. Bus stop 5 must travel from node 1 to node 2 to node 4 and arrive at node 5 with a total of 38. There is a 31-kilometer distance from node 1 to node 3 to node 6. And node 7 has a route from node 1 to node 2 to node 4 and finally to node 7 with a traveling distance of 43. We shall now solve the problem using minimal spanning tree. Help Jimmy find the minimum distance needed using minimal spanning tree. First, select any node from the network and select the closest node to join the spanning tree. Here, we selected node 1 and the closest among nodes 2, 4, and 3 is node 3. Next, select the closest node not presently in the spanning area in order to not create a cycle or an enclosed network, the closest node being node 4 among nodes 2 and 6. Continue until all nodes are selected without forming a cycle. figure shown is the final route using minimal spanning tree.
And that's all for today.
We hope we help you with our discussion.
Tune in next time for more lessons on operations research.
This is Mac.
See you next time. Bye!